Hi, beautiful people. Today we're talking about this question right here. Would you rather be the first person to discover and explore an inhabited planet? So you're going to be the first person that finds a planet where things are living there. Could be microorganisms, could be whole societies. That's up for you to think about. Or would you rather be the person that invented a drug that cures a deadly disease? Either way, you're getting into the history books. I just wonder what your thoughts are on which one of those would be more interesting. I've chosen these two scenarios because they both are full of potential for exponential situations. Exponential situations, again, are distinct because they grow so quickly. We've talked about a couple of kinds of exponential situations. Exponential, where things are doubling each time, not just one time, but over and over and over again, and tripling over and over and over again. Doubling, of course, if it happens repeatedly, it's not 2x. It is 2 exponent x, or 2 to the power of x. Those are very different. Similarly, tripling, because it's happening more than one time, it triples again and again and again, is not just 3x, it's 3 exponent x. And if you're curious, either with a graphing calculator on Desmos, you could graph those things side by side and see, although they start very similarly, 2 exponent x grows much faster than 2x. It leaves it behind completely very quickly, as does 3x versus 3 exponent x. But life isn't always so simple. Things don't always just double or triple. I will say, if you see a word problem or you hear someone talking on the news about something doubling or tripling, for example, if you're hearing on the news that infected people are doubling every 3 days, that's exponential growth. But sometimes we don't all hear the phrases double or triple, and they could still be an exponential situation. If you hear words like double or triple, we already know that's exponential. But if you hear the word percent increase or percent decrease, that's also exponential. So, for example, we're going to write our formula y equals a parentheses 1 plus r parentheses t. Now, a is going to be the initial amount. And let's think about our zombies, right? We knew that our zombie story was 2 exponent x. What was our initial amount of zombies? Just Miss Wise, right? Just 1. Okay. And it doubled each day, and the one person that was infected could infect how many more? 1 more, right? And this is going to be looking like doubling because guess what? 1 times 2. And then we wrote our day instead of x, we wrote it t. It really doesn't matter. The t is just there to help you remember that the exponent represents time. But whether you say it's t or x, that's okay. If we were to simplify this, obviously 1 times 2 simplifies to 2 exponent x. So yesterday and the day before, when we were talking about doubling and tripling, we were using this formula. But it wasn't so hard that we had to write this all out, right? This is just a lot of wasted space. If you hear doubling, it's easier just to know. This is 2 exponent x. But sometimes you're not given such an easy problem. Life is far more complicated. So, as I said, A is initial amount. That's where the A comes from. R is rate or percent. T stands for time. So let's read these situations that happen in our world and see if we can't model them using an exponential function. Annual sales for a company are $149,999. And these sales are increasing at the rate of 6% per year. Hear that word percent? That means exponential. And then it tells us, of course, use an exponential function to model this, and they want us to find how many after 7 years. Okay, so our initial amount, the amount we're starting with, is this amount, 149,999. And then we're always going to have 1. You can see that 1 is part of the formula. It's just you always have a 1 there, just like you always have those parentheses. And then the rate is, it says 6%. Now, we need to remember back to middle school. How do we write 6%? Now, of course, the word cent is close to its cousin, the word percent. They both mean out of 100. A cent, there's 100 pennies in a dollar. So there's 100 cents in $1. And of course, say we're taking a test, we know there's 100% on the test. So how would you write the word, how would you write in decimal form 6 cents? Of course, it's 0.06, right? That's the exact same way you'll write percents, 0.06. So imagine what it would look like as a cent, as money, and that will tell you how to write it as a percent. So we're going to have 1 plus 0.06, and then we need to take a look at our word problem to find out time, and they want to talk about 7 years. Sometimes it can be months, that is the unit for years, days. In this case, it's just 7 years. Okay. We are going to put this in our calculator. You can use a calculator on Desmos. You can use a calculator on Google. I'll give you a few seconds to try that out. Okay. So will you put that in our calculator? I'll go ahead and put it in mine. 1, 4, and then 4 nines, 9, 9, 9, 9, 9. Parentheses, 1 plus 0.06 parentheses. And then you're going to use this button here, if you're using a graphing calculator, to type in a 7 for 7 years. And we're going to get a very large number. 2, 2, 5, 5, 4, 3, and 4 cents. So it is 225,000 after seven years. And what that means is this year, let's say year 2020, they're making every year, they're making $149,000 every year in sales. But in 7 years, they've increased their annual sales to not quite double, but they're getting there. They're getting closer. So as you can see, doubling, tripling is an extreme example of exponential growth, but it still happens pretty fast. Another one that's interesting, especially as we talk about inhabited alien lands, let's think we're talking about a population in one of our towns. And then you can kind of imagine it if you've seen Star Trek and those kinds of things, trouble with tribbles or something. What might happen to us if we were introducing new species onto our planet. Okay, so this is, I guess I don't need to write number 5 because I don't have the notes. It's okay. The population of a small town is 1,600 and is increasing at the rate of 3% each year. And again, we heard that word percent. So we would write y equals A. We're going to think about what is the initial amount, the starting amount. 1 plus a rate of increase or decrease. In this case, it's increase, so that's why I wrote plus. And then the time they're interested in thinking about. Our initial population was 1,600. We're always going to have a parentheses. We're always going to have 1. Our rate of increase was 3%. Again, think, how would you write 3 cents? 0.03. And the time they're interested in is 10 years. So we have an exponent of 10. I'll let you check that out. See if you can do it in your calculator. I will tell you it's over 2,000. So hopefully you got an answer close to that. I want to, before we go, talk very quickly about what happens with exponential decay, Because again, this happens in real life. If you're having chemotherapy, for example, your cancer cells are decaying at an exponential rate, things like that. So I want to take a look at decay, and what's cool about decay is that it's almost the same. You're still thinking about a function, y or f of x. You're still going to think about an initial amount. You're going to have a parentheses each time. You're going to have a 1. You're going to have a rate. You're going to have time. So these are the same as above. A equals initial amount. R equals rate or percent. Hear that? R? T equals time. The only difference is that exponential growth has an addition sign, a positive plus sign, a sum, and this has decay has a decrease. So an increase or growth equals a plus sign. Decay or decrease equals a minus sign. And that's literally all you'd be changing. For example, let's take a look at another population question. The population of a town is decreasing at the rate of 2.5% per year. If the population in 2000 was 28,000, what is the expected population in 2015? Now this one gets a little bit more complicated because instead of saying 10 years, they give us 2 different years to think about, and we have to think how many years would go between that. It also gave us, instead of a number like 20% or 6%, it gave us a tricky number like 2.5, which has a decimal already in it. Okay, so that's why I want to take a look at this problem. In part because you're going to see complicated stuff on the news, when you read newspaper articles, when you read science text, and as you move into the adult world, because exponential functions are kind of all around us. So let's take a look. Our initial amount. The population in 2000 was 28,000. That was our initial amount. We're always going to have parentheses. We're always going to have 1. Let's take a look at our rate. It's 2.5%. Is it possible to have 2.5 pennies? Not really. So let's just think about 2 pennies. How would you write 2 pennies? 0.02. So here you're just going to do your 0.02. You're just going to stick that 5 on there. Because what essentially you've done is you've moved the decimal over 2 places. Okay, so 28,000 times 1 plus 2.5% written as 0.025 with time. Now they're talking to us about 2000 all the way to 2015. How many years is that? 15. All right, I'm going to use my trusty calculator because I do not have a clue what 1.025 is multiplied by itself 15 times. That's not math people are supposed to do. Maybe the aliens on this planet can do it, but we're not supposed to do it. Okay. 28000 parentheses 1 plus 0.025 parentheses exponent 15. Oh, I pressed graph. Don't do that, Jessica. Enter. Oh, heavens. Okay, so in 2000, even though they're only growing at 2.5% a year, which is pretty small, right? Very small amount. They're going to go from, in 15 years, 28,000 people to 40,552 people. And then the calculator will give you this. Y'all, can we have 0.34 people? Like maybe in some way we can, like unborn babies or something, but that's weird, okay? So in the real world, we're not going to round that up or down. We're just going to take off the decimal, and that would be our population. Okay, so given this foray into exponential growth and decay, I'd love to hear whether you would rather be the first person to discover and explore an inhibited planet or be the inventor of a drug that cures a deadly disease. I look forward to reading your comments, and I will see you tomorrow. Bye-bye.